Alright guys, so this is a lesson on solving problems that have decimals, but also making sure that you follow order of operations. There we go. Because no matter what kind of problem you're working through, if there's more than one step in order to solve the problem, you still need to be thinking about order of operations. So by the end of this lesson, you guys will be able to do decimal problems using all four operations successfully while following order of ops. So remember, what is our order of operations? How do we know what to do first? Well, remember, there's a few different ways to remember it. Back in chapter 1, we talked about, please excuse my dear Aunt Sally, PEMDAS, purple elephants may destroy a school. We created a order of hop, kind of looks like hopscotch. But those letters are all supposed to help us remember a certain mathematical operations. Remember, P is supposed to let us remember about parentheses or any other grouping symbol. Now remember, those come first if there's something to do within those parentheses. Fraction bar also acts as a grouping symbol. So if there's an operation to do inside of these, or in the numerator and denominator, then you do that first. If there's simply just a number in parentheses, and that's it, then there's nothing to do there. So then you move on to the next operation. E stands for exponents. So for example, if I have 3 to the second power, I would say that that's 9. I would simplify that. Okay, those are exponents. M and D are next to each other because it's whatever comes first from left to right. So that's multiplying and dividing, but it's not always multiplying first and then dividing. It's whatever comes first from left to right. So if you have, let's say, 45 divided by 9 plus 6, not plus 6, I want to do times 6 there. There we go. Then you would have to do, I'll get rid of my division sign. You have to do the dividing first and then the multiplying. So 5 times 6 would give you 30. And then same thing for adding and subtracting. It's not always adding first and then subtracting. It's whatever comes first from left to right. So if you have 7 minus 4 plus 9, you do 7 minus 4 first. Then add 3 plus 9 to get 12. So let's look at that when it comes to decimals. So example 1, we have 2 4/10 times 16 plus 7. So don't just work your way from left to right with each problem. Make sure you think about your order of operations. So in number 1, I have multiplying and addition. So the first thing I'm going to do is multiply. 2 4/10 times 16. Now remember, multiplying with decimals, the trick is to just pretend like the decimal's not there when you set up the problem. So I would be thinking about this like 24 times 16. Now once I've set it up, then I can sneak that decimal back in there. But remember, you're not lining up decimals like you do with adding and subtracting. So go ahead and multiply like you normally would. 4 times 6 is 24. 2 times 6 is 12 plus 2 is 14. You still do a placeholder 0 just like you would before. 4 times 1 is 4. 2 times 1 is 2. You add. Now, though, this isn't my answer because I need to figure out what about my decimal. Well, I look at my two factors here. This number had one number to the left or the right of the decimal. This had no numbers to the right of the decimal. So I need one number to the right of the decimal in my answer. So remember, you're always starting here. 1 to the right means 38.4 is 2 4/10 times 16. So that's my answer to this part of the problem. So this was 38.4, and then I'm going to rewrite the rest of the problem plus 7. So now I need to do that. Now remember, for adding, I need to line up the decimals. Well, where's the decimal in the 7? Don't see one? Remember, if you don't see one, that means it's at the end of the number, all the way to the right. This is the same as like 7.0, 7.00. I could add as many zeros as I might need to make it work for my problem. But hopefully you guys can see there, we're just going to need 1. So I'm going to line it up horizontally. 38 4/10 plus 7 0/10. Now my decimals are lined up. Now I can add. 4 plus 0 is 4. In adding and subtracting, you just bring the decimal on down. 8 plus 7 is 15. Carry the 1. 1 plus 3 is 4. So our final answer there is 45 4/10. Let's take a look at number 2. 4.32 next to parentheses that has 3.7 plus 1.65. So what do we do first? parentheses are gonna come first. So we have another operation to do inside of there. We're adding. So let's go ahead and add. I need to line up the decimals. So 3.7 plus 1.65. The decimals are lined up, but what goes here? Remember, you can fill that in with a placeholder 0, and now we can add. Bring those decimals down. So these two numbers add up to 5 and 35 hundredths. I'm still going to keep the parentheses because there was a number right next to it. And hopefully you guys remember from chapter 1 that a number right next to parentheses means we need to multiply. So set it up like a multiplying problem that has no decimals. So I'm going to treat it like it's 432 minus 5 or times 535. I'll put the decimals back in once I set it up. This is 3-digit times 3-digit, so we have some work ahead of us here. 2 times 5 is 10. 3 times 5 is 15, plus 1 is 16. 4 times 5 is 20, plus 1 is 21. Now, this was a 0, but it was a 0 because I did 2 times 5. I still need my placeholder 0 for my second row. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. Now I need 2 placeholder zeros. 2 times 5 is 10. 3 times 5 is 15, plus 1 is 16. 4 times 5 is 20, plus 1 is 21. Remember, lining things up is very important with decimals. Making sure this is all lined up appropriately is really, really important. 2 plus 2 is 4, plus 6 is 10, plus 1 is 11. That's 3 and 2. Now, where does my decimal go? Well, I had 2 numbers behind the decimal here and 2 numbers behind the decimal here. So 2 plus 2 is 4. So I need 4 numbers behind the decimal. So that means start from here and work your way back. 1, 2, 3, 4 numbers behind the decimal. 4 numbers, including any zeros, you get in your answer. Now, do you really need that 0 in your answer? You don't. So technically, you could really write this as 23 and 112 thousandths. You don't really need the 0. If you include it, that's fine. But if you were checking this like in the back of a textbook, that's how they would write our answer. Now let's look at number 3. 23 and 98 hundredths minus 1 and 7 tenths squared times 7.6. Let's think about order of operations. What would we do first? Hopefully you're saying to yourself, exponents. So 1.7 squared, remember, means 1.7 times itself twice. 1.7 times 1.7. So 7 times 7 is 49. 1 times 7 is 7 plus 4 is 11. Placeholder 0. 7 times 1 is 7. 1 times 1 is 1. I get 289, but I need to put my decimals in. There was 1 number behind the decimal here and 1 here, so I need 2 in total behind the decimal. So 1, 2. 2.89 is this part of our problem. So now we've got 23 and 98 hundredths minus 2 and 89 hundredths times 7 and 6 tenths. So what comes next? Multiplying. So I've got 2 and 89 hundredths times 7 and 6 tenths. Set it up as if there's no decimals and then plug them back in. 9 times 6 is 54. 8 times 6 is 48, plus 5 is 53. 2 times 6 is 12, plus 5 is 17. 9 times 7 is 63. 8 times 7 is 56, plus 6 is 62. 2 times 7 is 14, plus 6 is 20. Ooh, running out of room there. Add that all up. Now look back, we had 1, 2, 3 numbers behind the decimal. So 1, 2, 3. 21 and 964 thousandths is this part. I don't know if you guys noticed, but with my work here, I kind of have this work off to the side that's doing each step. Pizza slice work doesn't really work when you have decimal problems in order of operations because it just takes up too much space. So I usually have like a side part here where I'm doing each step. I still underline though and then come back and write the final answer for that part of my work so that I can keep organized and remember what I need to do next, where this number goes in the problem. Those are all important things. So now my last thing to do be subtract. Now remember with subtraction, order matters. the number on the left, the first number has to be the top one when I set it up vertically. So it has to be 23 and 98 hundredths on top. It has to be 29 and 964 thousandths on the bottom. It's not the longer number that goes first, it's whatever one was first written in your problem, first from left to right. So that means I gotta add in this placeholder 0 here. Can't do 0 minus 4, so I'm gonna have to borrow. 10 minus 4 is 6, 7 minus 6 is 1, 9 minus 9 is 0, 3 minus 1 is 2, 2 minus 2 is 0. I brought my decimal on down. So 2 and 16 thousandths is our answer for number 3. Number 4, 7 and 68 hundredths plus 3 and 18 hundredths divided by 12. What do we do first? Division. So remember, set it up. This is your dividend. This is your divisor. So off to the side here. I'm going to set that up. I want to include all my decimals right now. Remember, the rule for dividing is your divisor has to be a whole number. Well, it already is. Great. If it wasn't, I would move my decimal until it was a whole number, and I would move this the same amount of spaces. But it is, so I'm good. So I'm not moving any decimals. The only thing I'm going to do is make sure that the decimal, my dividend, is in the same spot in my quotient, in my answer. Really, really, really important to make sure all your numbers line up in the right spot here when you're writing numbers up here, or else you're going to mess up your answer. So does 12 go into 3? No. So I'm going to put a 0 there. So I know this is going to be 0 point something. Does 12 go into 31? I now treat this as if that's decimal isn't there. So I'm thinking of this as 31, not 3.1. Well, yeah, 12 does go into 31. How many times? 2 times. 2 times 12 is 24. 31 minus 24 is 7. I bring down a number, 78. 12 goes into 78 how many times? 6 times. 6 times 12 gives you 72. And I get 6. There is no remainders with decimals, right? So I have to keep going. I can't just say 26 hundredths remainder 6. That doesn't make any sense. So what do? 12 doesn't go into 6, but I didn't bring a number down yet. Well, I'm already behind the decimal, which means I can add as many zeros as I might need to make this problem work and eventually end without a remainder. So I'm going to bring down my one number for free, my 0. And now ask myself, does 12 go into 60? And it does. 5 times. Now I get 0, so now I'm done. So 265 thousandths is my answer for this part. So I still have that 7 and 68 hundredths plus this answer, 265 thousandths. So now I need to add, so I'm going to line up my decimals. I don't have a number here, so I can fill in a 0. I don't have a number here. This can also be filled in with a 0. And then we add. Bring those decimals down, and you get 7 and 945 thousandths. Now that you're done watching this video, go ahead and try some problems on your own on the worksheet.